Hi everyone, this is Miss Deaver. Welcome to my online classroom. Algebra, this is Chapter 3, Lesson 2, Solving Linear Equations by Graphing. Okay, in the past you've graphed linear equations by using tables, by finding roots or x-intercepts, by finding zeros, and finding x and y-intercepts. What you're going to do today is solve linear equations by graphing. You'll also be solving linear equations by estimating solutions to a linear equation by doing some graphing. What I want you to keep in mind is that today what you're going to be doing is looking for x-intercepts, and you're either going to solve it algebraically and prove that it's true, or you're going to solve it by writing a related equation in slope-intercept form and putting an expression or an equation on the graph. Alright, so we have some new vocabulary. A linear function is the function for which the graph is a line. A parent function, or the function given the input of x, is called the parent function of a family of linear functions. A family of graphs is a group of graphs with one or more similar characteristics. And a root is the solution or the root of any equation that makes the equation true. The zeros are the values of x for which f of x, or the function value given the input of x, is equal to 0. And these are known as the zeros of the function. If you could keep in mind, there's a really great example in your textbook on page 163, and it talks about the fact that x-intercepts, solutions, and roots and zeros are really all closely related. And that's what you're going to be working with today. Remember, everything we do in this lesson is really to find the x-intercept if there is one. Sometimes when you find x-intercepts, you'll find out that the line does not cross the x-axis, which in that case you would have a horizontal line. And you can prove that algebraically, and then you can write a related equation and be able to find that y is equal to a number, and that will make a horizontal line on the graph. Okay, so the key concept here is linear functions, and here's an example of a parent function. F of x equals x, so given the value of the function, given the input of x. And the type of graph we have is a line graph, where all real numbers are true for the domain, and the ranges also includes all real numbers. Alright, so let's look at solving an equation with one root. And when we say we're going to solve an equation with one root, we're talking about the fact that we're finding one x-intercept. Now, linear functions will only have one x-intercept if they have one. It's possible you could have a horizontal line that does not have an x-intercept or a root at all. So when we're solving this, we have 0 equals 1/2 x plus 3. So if we're going to solve something algebraically, we know that when we put 0 in for y, we're finding the x-intercept. And that's what's happening here. We actually put 0 in the place of that y, and we're solving it for the x-intercept. So let's solve it algebraically. We have the original equation. We're going to subtract 3 from each side. Now we're going to multiply each side by 2, and we find out that we do have a solution. We have -6 is equal to x, and so the solution here is -6. Because if we put -6 back in the place of x, it would make a true statement. I would have a -3 plus a +3, which is equal to 0. So in this case, we do have a solution. So we know we have an x-intercept. Now let's look at the next example. Let's solve this equation with one root. So we have 2 equals 1/3 x plus 3. And in this method, we want to solve it by graphing. So you have two different ways you can solve it. You can solve it algebraically, or you can solve it by graphing. In order to solve it for graphing, we need to write a related function. That means that we need to get it into slope-intercept form. So we have 2 equals 1/3 x plus 3. We're going to subtract 2 from both sides of the equation because we want to set the equation to 0. We know that if we put 0 in the place of y, this would give us a related function because we can take out the 0 and put in the y, and you would have y equals 1/3 x plus 1, which would be slope-intercept form. When we do that, we could do it with a table. You can make a table to get a graph, to graph the function. You can make a table, or you can simply put it into a related function and graph it straight from the related function. So if we were putting this into a related function, into slope-intercept form, it would look like this. And so I want to do this at the very bottom to show you. I would do, instead of f of x, I would put in 0 equals 1/3 x plus 1. And know that that 0, we could put y in the place of that f of x, or we could put 0 in the place of that f of x. And now let's subtract 1 from both sides. And if I want to get x alone, because I've put 0 in the place of y, so I'm solving for the x-intercept, I would multiply both sides by 3/1. These would cancel out. If whatever I do to one side, I must do to the other, and I would get -3 is equal to x. And so that's how I know that the graph intersects the x-axis at -3, because when x is -3, y is 0. Now I can see that right here. Right here. I can see that. That's where it intersects the x-axis at -3. The table helps me get the line on the graph. I know that this is a positive function. I know that my y-intercept is +1. So for every 3 changes in x, I have 1 change up on y. So this is a positive graph. Alright, let's look at the next example. Alright, here's an example of -2 equals 2/3 x plus 4, and they want us to solve it algebraically. So let's see if we get a solution, which is really our x-intercept. So I have -2 equals 2/3 x plus 4. So I want to subtract 4 from both sides. Remember, I'm solving for x here. I get -6 equals 2/3 x. Multiply both sides by the reciprocal of 3/2. Multiply this side by 3/2. I'll simplify here. And I get -9. All of this will simplify out, equals x. And so that means that that is the x-intercept. The x-intercept in this case is at -9. Alright, now let's look at this example. It says 6 equals -3/4 x plus 9, And we can also find the x-intercept by graphing. And this is where we would write a related function in y-intercept form. So I would take 6 equals negative 3/4 x plus 9, and I would subtract 6 from both sides. Remember, what you want to do is set your equation to 0 so that you can get it in y-intercept form, and you can replace that y with a 0. They're interchangeable because if you're putting in 0 for y, you're solving it for the x-intercept. So this goes away, and I have 0. I have negative 3/4 x plus 3. And now I have a related function that looks like y equals negative 3/4 x plus 3. So I know that if I put 0 in the place of y and solve it for x, then I'll get x equals 4. And you might want to, you just subtract 3 from both sides. Then you would multiply both sides by negative 4/3, and you're going to get x is equal to 4. And so, of course, your graph here, you know that this is a negative graph in your related function, and that your y-intercept is 3. This is the y-intercept at 3. I know it's a negative graph, and here's my x-intercept at 4. And so my answer would be A. Alright, let's solve an equation where you don't get a solution. And the reason you don't get a solution sometimes is look at your equation. Do you see a y value anywhere in there where it's possible that you won't get a solution? It's possible that this could be a horizontal line where with no x-intercept. So sometimes when we solve for an x-intercept algebraically, we'll get a false statement, which means there's no x-intercept. And so let's look at this, solving it algebraically. You have 2x plus 5 equals 2x plus 3. We're going to subtract 3 from both sides. That will give us 2x plus 2 equals 2x. And now we actually have, if we subtract 2x from both sides of the equation, we actually have a false statement because 2 cannot equal 0. That means that we don't have an x-intercept. It's a false statement. We don't have an x function value for x that when we put that in for x, it will give us a true statement. So the related function, or the function value given the input of 2, the root of the linear equation is the value of x when f of x is 0. And since f of x is always going to be equal to 2, this function has no solution. So now let's look at another one. 5x minus 7 equals 5x plus 2. And let's solve this one graphically. Just because a function doesn't cross the x-axis doesn't mean that you can't graph it. You can graph it. What we're simply going to do is set this equation to 0. Let's see if we can get a value here. Let's see if we can get a related equation. So we're going to solve it graphically. So we're going to start with 5x minus 7 equals 5x plus 2. And we're going to subtract 2 from both sides of the equation. Negative 7 plus a negative 2 is negative 9. If we subtract 5x from both sides of the equation, we get negative 9 is equal to 0. So that means that this particular line does not intersect at the x-axis. So the graph the related function. You're taking out this 0 right here. We're taking this and writing a related function. of negative 9 equals y, or negative 9 equals f of x. That means the function value is negative 9. So if we graph this, notice that it graphs as a horizontal line. Whenever you've got that 0 there, you can put y in its place and it'll graph as a horizontal line. Therefore, there's no solution. And what they mean by no solution is the fact that there's no x-intercept. Alright, here we go. We have negative 3x plus 6 equals 7 minus 3x. And they want us to solve it algebraically. They're not asking us to do it graphically. They're asking us to solve it algebraically to see if there's an x-intercept. So I have negative 3x plus 6 equals 7 minus 3x. So I'm simply going to subtract 3x from, add 3x to both sides of the equation, and you get a false statement. 6 cannot equal 7. So that means that there's no x-intercept, and that's considered to be no solution. Doesn't mean you can't get it on the graph. It just means that there's no solution for the x-intercept. There's not an x value that we can put back in this equation to make a true statement. Alright, let's look at the next example. So now this time, they want us to solve it by graphing. And you know that if you're going to solve something by graphing, you're going to have to write a related function. So if we have 4 minus 6x equals negative 6x plus 3, then what I'm going to do is I'm going to add 6x to both sides of the equation, and I get 4 does not equal 3. Well, that means there's no x-intercept. But if I want to put this on the graph, then I want to set the whole equation to 0. So I'm going to do 4 minus 6x. I'm going to add 6x to both sides of the equation, and then I'm going to subtract 3 and set it to 0, because I know I can take out that 0 and put in a y. Notice the two middle terms cancel completely out, and a 4 minus 3 is 1. So 1 equals 0, and I know that that 1 is the f of x, because I can take out 0 and put in f of x. I can take out the f of x, and I can actually put in y. And we know that that's a function. So we can see that it can be graphed this way, but as far as the lesson is concerned, it has no solution because it has no x-intercept. But it can be graphed. Alright, Kendra's class is selling greeting cards to raise money for new soccer equipment. They paid $115 for the cards. They are selling each card for $1.75. The function y equals $1.75x minus 115 represents their profit y for selling x number of greeting cards. Find the 0 of this function. When it says find the 0 of the function, we're looking for the x-intercept. Describe what this value means in context. So make a table of values, and if you sold 75 cards, you'd make $16.25. If you sold 100 cards, you would make $60. Now let's see what it looks like on the graph. Notice that if you sell 75 cards right here, about 75 is right here. If you go straight up here, then you have it's between $10 and $20. The algebra shows us that it's $16.25. for 100 cards, if we look at 100 cards right here, and we go straight up the graph to that point, we're going to see that it's about right there at $60. So the zero of this function, the graph appears to intersect the x-axis at about 65. That's the zero of the function. So next, solve algebraically to check to see if you're correct. So if we have y equals $1.75x minus 115, that's our original equation. We're going to replace that y with the 0 because we know if we put in 0, we're solving for the x-intercept. We're going to add 115 to both sides of the equation and then divide by 175, and you're going to get approximately 65.71 cards. Now the reason we're getting an approximate is because we can't sell part of a greeting card. They have to sell 66 greeting cards to make a profit. Alright, let's look at one more. On a trip to his friend's house, Raphael's average speed was 45 miles per hour. The distance that Raphael is from his friend's house at a certain moment in the trip can be represented by distance equals 150 minus 45 times t, where d represents the distance in mile and t is the time in hours. And it wants us to find the zero of this function and describe what this value means in the context. Well, here's your choices. Three, Raphael will arrive at his friend's house in 3 hours. 3 1/3, he'll arrive at his friend's house in 3 hours and 20 minutes, because 20 minutes is 1/3 of an hour. Or Raphael will arrive at his friend's house in 3 hours and 30 minutes. Or D4, Raphael will arrive at his friend's house in 4 hours. And so this is the way I would solve it. I would rewrite this a little bit and put it more in slope-intercept form. D equals let's see, negative 45t plus 150. And then I would take out the d and put in 0. I would subtract 150 from both sides of the equation. That's a negative 45t. And then I would divide both sides by negative 45. A negative divided by a negative is a positive, and that's a good thing because time needs to be positive unless you're doing time traveling. And then I would get about 3 1/3 hours of time. And so your answer has got to be B. Hope this helped you some. Just remember that if you can keep your vocabulary straight and really understand that if you're finding the zero of a function, you're finding the x-intercept. And if you're finding the solution in this particular case in this lesson, we're talking about the function given the input of x that makes the equation true. Thank you and have a great day.